Guys, in this video we are going to see an example of op amplifiers. In this particular problem we have asked to find out this Vout voltage. Okay, now when we deal with op amplifiers we have to know two things. We have to know that whatever the current entering or exiting these positive negative terminals is always going to be zero, so there's no current entering or exiting. Okay, and also we have to know that voltage across this negative terminal is equal to voltage across the positive terminal. So these are the two things we have to know when we deal with op amplifiers. Here the question is for to find out this V out. Now let's look at this one. Here we have V5, that's unknown, and also we have a dependent current source that is 10 to the power of minus 3 V5. So we have to solve for this V5 first, right, in order to find what current is this one. Now to solve this V5 we can use the voltage division, because we have 1K resistor, 100 ohm resistor, and here we have a voltage source provided. So we can calculate this V5 using voltage division. So voltage division is basically, so we are trying to find V5. V5 is going to be equivalent to V source times this. This is the top resistance, 1K divided by 1K plus 100, and that's going to give us the V5 voltage. And we know that V source voltage, that is 2 cos 100t millivolt times, this is going to be 1000 divided by 1100, and this is going to be basically 10 over 11 multiplied by this one. We are going to get 20 cos 100t millivoltage divided by 11. So this is going to be the V5 voltage. Now let's see how we can use this one to find out Vout voltage. Okay, and here we know this is connected to the ground, so voltage across this positive terminal is going to be 0. So if voltage across the positive terminal is equal to 0, then voltage across the negative terminal also equal to 0. Okay, so we know that these two are going to be equal to 0. So we know the voltage across this one, this is going to be 0 voltage, and this is what we are trying to find. Now we have to know what's the current going through this one, because if we find that one we can calculate the voltage easily. Now if you look at this one, here we have this one connected to the ground, so voltage across this one is 0. If the voltage here is 0, this is also 0, so the current through this one is going to be 0, because 0 minus 0 divided by 1K, that's going to be just 0. Okay, so the current through this one is 0 ampere. Therefore this is the current coming through this one, and this is not definitely coming through this op amplifier, because we know that current entering or exiting this op amplifier is always going to be 0. So this 10 to the power of minus 3 V5 current definitely comes from here. Okay, so this is 10 to the power of minus 3 V5 current. Okay, so we can now find out this V out using, like, V is equal to I times R. We have the resistance, we have the current, so we can calculate the V out voltage. So V out voltage is going to be 0, this is 0 voltage plus this voltage, that's going to be 3K times 10 to the power of minus 3 V5, and 3K, K and 10 to the power of minus 3 cancels, and we are left with 3V5, and we found out V5 already, right? That's 20 cos 100t millivoltage divided by 11, and if you multiply that one with 3, you are going to get 60 cos 100t millivoltage divided by 11, and that's going to be the V out voltage. And that's how we do this kind of problems. I hope this helps. Thanks for watching.